It was August 23rd, and I was staring at the television. Chandrayaan-3 was about to land on the moon, but the memory of Chandrayaan-2's crash was still fresh. I was thinking about what kind of algorithms they were using. Wouldn't it be cool if we could just automate the whole thing? So, I dove into OpenAI Gym. The Gym is a toolkit designed for the development of reinforcement learning models. It acts as an interface between algorithms and the environments. After a bit of reading docs,
One eternity later.
I was ready to build my own 3D lunar landers. I started by creating the environment, which consists of the lander, the target place, and the surface of the moon. I created these using a game engine called Ursina in Python. The engine was great except for the fact that I had to implement all the physics. Somehow, I pulled it off. Now it's time to put our game into an OpenAI gym. I defined 6 actions: thrust, 4 directions of movement, and idling. Simple enough, right? Wrong. I had to make sure the lander didn't just go careening off into space. After a bit of tinkering with the values, I was satisfied with the lander. Next is the observation. This is the values that the model will look into before taking an action. This changes after every action, so we have to give it to the model at each step. For the model's observations, I gave it the target's location, the lander's position, and its velocity. Now comes the tricky and most important part, the reward function. For the model to understand if it has made a good decision, it needs some indication. We provide this indication in the form of a reward value. The main objective is to reach the target position. We reward the model with a positive value if it moves towards the target and a negative value if it moves away. Finally, to train the model, I use stable baselines, a collection of reinforcement learning algorithms. I chose the PPO algorithm for training. After what felt like forever, the model started reaching the target, but let's just say its landings were a bit forceful. To encourage a gentler touchdown, I fixed an altitude threshold. Below this threshold, we want our lander to descend as slowly as possible. To achieve this, we penalize the model based on its descent speed. Finally, after countless training sessions, the model learned to land like a prof. It's like watching a baby gracefully learn to walk, except, in a spaceship.